welcome to the last video in this proof series. In this proof, we are going to prove that perpendicular bisector theorem. And that states that if a point is on the perpendicular bisector of a segment, then it is equidistant to the endpoints of the segment. So what that is going to mean is that that point C is going to be the same distance from A as it is from B. So we are given that CP, the line, is the perpendicular bisector of segment AB, and we're asked to prove that CA is going to be congruent to CB. That's saying that A is the same distance apart from C as B is from C. And we can see that we've drawn in a couple segments there that's going to make this look like a triangle. So we're going to start with what we are given, and that is that the line CP is a perpendicular bisector of segment AB. Our reason is going to be given. On the next step, we're going to explore just a little bit more about what it means to be a perpendicular bisector. A perpendicular bisector means it's going to cut segment AB into two congruent pieces. You see that marked in the diagram, and you can also use that from the definition of the perpendicular bisector. So really you could go with either one there. You could go given because it was marked in the diagram, or you could mark it as the definition of a perpendicular bisector. So they have already marked that on our triangle for us. So we now have one side congruent. As you've probably guessed by now, we're going to be trying to prove that we have some congruent triangles. You've probably noticed the pattern that when we have two different triangles within an image, we're going to be aiming towards getting those to be proven congruent. Alright, so we're going to stick with our definition of a perpendicular bisector and what else it tells us. It tells us that it's going to make a right angle because it's perpendicular with AB. So that is going to make APC a right angle, and it's going to make CPB a right angle. And that is, again, the definition of a perpendicular bisector. Now, since those are both right angles, we can say that angle CPA and angle CPB are going to be congruent based on the right angle congruence theorem. So we now have a side and we have an angle, specifically a right angle. We'll see if that comes into play. Alright, so looking at what else we can prove from this, we're going to have a segment that's included in both triangles. So as we've seen when we've been able to do that so far, whenever we have a line that's being shared, by the reflexive property of congruence, we're able to say that it's congruent to itself. So PC is going to be congruent to PC by the reflexive property of congruence. So we now have a side, an angle, and a side, which is one of our 5 ways that works to prove a triangle is congruent. So because triangle APC is congruent to triangle BPC, we can say that by the side angle side postulate. So we now know that these triangles are going to be congruent, so that means their corresponding pieces are going to be congruent. CA is a corresponding side with CB. Since we have proven these triangles are congruent, we can say that those segments also are congruent since they're corresponding sides, and we say that by CPCTC. Alright, that wraps up this proof video series. We look forward to seeing you guys in the next one.